Hey everybody, what's going on? This is Miss Cologne here. I'm going to show you a short video on corresponding parts. Based on the previous video, I had to explain what a scale copy is. I just didn't get to the specifics on the different measure lengths, angles, points. Those are going to be the specifics we're going to look for now to determine if a copy is a scale copy of the original. So we got to first think about what is corresponding parts. That iffy word, corresponding. So corresponding parts is typically parts that are in the same location. So placement is viable in this scenario. So it needs to be in the same place. Basically, if I was to take that shape and I place it over the original, wherever that part is going to overlap the exact same spot. So corresponding parts has to be in the same location. Okay. But obviously they're not going to be an exact original figure. It's going to also be in the other figure. We're going to call it the opposite or the copy figure. So three things come to mind. We're thinking, okay, the side links got to be in relation to each other, right? There's got to be a pattern. We're going to learn that in the next video, what that pattern is. Well, for now, this video is more for labeling purposes. So we're just trying to label our corresponding parts. We're not going to get down to the formulas yet. That's going to be in the next video because that will be the next term. Excuse me. So when I'm looking at a figure, and let's say this is the original copy, and figure two, let's say that's the scale copy. Now, I could have gone in reverse. I could have said this one is the original, this one is a scale copy, because it could go in both ways. For now, we're just going to make that assumption. So, when it comes to corresponding sides, there is criteria that it must be met before you find that magic number, and I brought it in the previous video. Before you find that magic number, you need to first determine if the shape is a scale copy. Now, before we used to just eyeball it, you could tell right off the bat it's a scale copy or it's not. Now, when they look too similar, it's hard to eyeball it. So, we're going to find the corresponding parts. First thing I want to look for is if there's any corresponding sides. Corresponding sides, again, you got to be specific in how you read it. I could say corresponding sides like this measure in figure one. Now, because it's on the left, and you see how the same shape is just a little bit bigger, that means this is a corresponding side. If I would have looked at another example, I could have said this down here is a corresponding side to this length in the other figure. And you will usually find a pattern that way. Another way to find your corresponding parts, if I wanted to label it, typically your points. Now, remember, with points and side length, they need to be in the same location. If I was to take this shape and place it over a point, so for instance, let's use this point for example. If I was to place this shape over this figure, this point will lay right on top of the same exact position this one is. This is on the top right corner of the shape. That means its corresponding point is also on the top right corner. You cannot say this is one point and then down here is a corresponding point to that. That cannot be correct. It needs to be in the same location. Now, corresponding angles work the same way. Angles are the measures inside the shape. So if I'm looking at this angle measure down here in the shape, in the bottom right corner, the corresponding angle to this one will have to be the exact same location on the bottom right corner as well. So notice that 3 corresponding parts has to take place. Sides or your segments, and I did not specify that, that is my apologies. These are also your line segments. You have corresponding points, and then you can have corresponding angles. So let's look at the example number 1 on the bottom. We're going to identify the corresponding sides. Now we're just doing sides, okay? So we're going to do it by color. If you want to draw these out on your own paper, you can. This is just already a drawn out figure for me. So we don't know which one is the original copy. We don't know which one is the scale copy. We just want to determine, are they scale copies of one another? Well, let's label what we know about the shape. So corresponding sides. Well, corresponding sides could be your leg segments, okay? It could be your leg segments. So for instance, I'm going to say segment A, your line segment A, corresponds with line segment D. And here's why I say it like that. Notice that, no, this shape is not right side up like the original, like the figure here on the left. So sometimes it may look rotated, flipped around. That is okay. If you would like to redraw that figure so that it looks right side up to whatever one shape is, that will be perfect. It would be safer for you, so then you can see it better on which side corresponds to which. Because this is a triangle, I know this was the pointier side, this was the shorter length. So if I was to flip this over, these would be the pointed side and that's the shortest length. So A went with D. So we're going to say A to D. Now, we're also going to say that this segment B, since it's on the left side of the triangle, corresponds to E, which is on the left side of the triangle. So we're going to say B to E. And then, lastly, segment C, which is on the right side of the triangle, corresponds to segment F, which is on the right side of the triangle as well. C to F. All we did was label what was on this side of the shape to its matching location on the other side of the shape. Let's do another one. Again, if I was to look at this shape this way, notice how this doesn't look right side up. It looks altered. If I were to flip my paper, you can actually see that this diagram matches it in this way. Okay? So, we're going to identify our sides. So let's say side A, which is on the top left side, needs to correspond with E, which is on the top left side, if I take my paper and rotate it back. So this is A to E. Okay? Well, segment B, which is on the top right side, must correspond with F, because it's also on the top right side. Again, as if I rotate it. So this is B to F. Okay. Segment C is down here, bottom right side. It is going to correspond with G, because it's also on the bottom right side. We rotate it. So this is C to G. And then lastly, segment D, bottom left side, which is going to correspond to H, which is on the bottom left side. So D 2H.